A user-friendly and AI-based mobile application to assist in trip planning using large language models. Um, Hi everyone, I'm Colleen Go, and I'm from Orange County School of the Arts, and I'm currently a sophomore in high school. Introduction. Over 93% of Americans are planning to travel within the next 6 months. And while travel can be exciting, it often comes with challenges. To avoid potential complications, it's essential to create a well thought out plan before embarking on a trip. Traveling with family and friends adds to get another level of complexity, as coordinating plans with companions can be difficult. For instance, you might create a travel itinerary for yourself and your friends, but once you share it, they may disagree due to differing opinions, often a result of insufficient communication during the planning process. To address these issues, we are developing a mobile application aimed at simplifying trip planning. Our mobile app will assist users in creating vacation itineraries, exploring places of interest, and asking questions about specific trips. We chose a mobile platform because it's the most convenient option. People carry their smartphones everywhere. One of the app's key features is helping users stay organized. When on vacation, there are often numerous activities and events to keep track of. So it's crucial not to miss anything, sorry. To ensure users remember their plans, we're designing a reminder page that tracks all scheduled activities. The app will allow users to easily set up and update their plans directly from their mobile devices. Our focus is on making the app user-friendly and intuitive, providing a more responsive experience compared to a website. Additionally, the app will work offline, allowing users to access their plans even without an internet connection. Um, Additionally, communication takes a big part when speaking of making a peaceful and happy trip. We want to incorporate a function that allows user to add their friends and talk friendly about their plans. Users who travel with others will never feel what they're making the plan alone. They can always talk to the people who they will travel with. This ensures communication that other trip planning tools do not offer. We designed an experiment to test out the effectiveness of different prompts for the AI to respond with the correct JSON format. In this experiment, we built 3 prompts, each asking the same question, but the difference is how they ask for the response format. The first one includes the JSON format in English words. The second one provides an example of how extra JSON could look like. And the third one added a pair of triple ticks for the AI to be distinguish the code from other words. We repeatedly sent each prompt to the AI 50 times and recorded the percentage of times where either the response contains any invalid characters or it is in a bad format. To our surprise, we found that the first message where we write out the format in English words performs the best. There were only 4% of times where the response was in a bad format compared to the other messages which had error rates around 20%. We determined why the result occurred was because large language models such as GPT-4 we used understands human languages better than code. Challenges. One of the challenges of making a mobile application is when users create chats with each other. We need a place to store messages and images in order to keep track of their chat history. We want to keep their information in a safe place to avoid privacy concerns. We also need to store the plans that they may as well as their reviews on a location. When they try to access these information, we also need to make sure that they can be retrieved instantly for the best user experience. To solve this problem, we could use cloud storage to keep all the data on a safe cloud platform, such as Google Firebase. When recommending music, we did not have in-depth knowledge of the culture of every location that we included in the app. This makes it challenging to manually select the list of music for each city. We could use AI to sort out the information of the popularities of different songs in each country, which allows us to give a list of popular songs to the users based on where they were traveling. Another problem we encounter is when we try to let the users be able to access the list of music recommendations. When users click on the button that says music recommendation, it shows a list of music and the artist next to them. However, a large language model like GPT does not naturally return responses in the list format. In order to show users list, we could engineer the prompt that we sent to the GPT API to have it return its response in the list format, and then retrieve the list by parsing and evaluating the response string we get. System overview. We use Flutterflow, an interactive web app, to build our mobile app with user interface. The app contains the following pages: login, creating vacation plans, searching and viewing cities around the world with music recommendation, add and chat with friends, speech-to-text generation with translations, and real-time assistant with AI. Specifically, the music recommendation, speech-to-text with translation, and real-time assistant pages are supported by our Python server. In Python, we connected to the OpenAI API and used generative AI to provide us with music recommendations, transcriptions of audio, and chat conversations with an AI assistant. In order to connect our Python code with Flutterflow, we built a Flask app to establish a connection. We also use the cloud database from Google Firebase to store the data and information we need. For example, we store the information of different attractions and chat boxes users use to contact each other. It saves users most recent edits, like the plans and reminders they make. We also used it for authentication purposes, like creating account and resetting passwords. The flow of our program will be the following. The user will first need to create an account on the mobile app and log in to access to other features. Then he can browse different attractions and create vacations, which then get stored in the Firebase database. He can also look for music recommendations or ask the assistant a general question about his or her trip. This request will be sent to the Python Flask app, which connects with the OpenAI API. The Gen AI will generate a response and send it back to the mobile app. And then this is an overview of my system. This is a diagram that shows it. And then this is a demo video. That's it. And this is some of my UI screenshots I took. So this is a vacation page, and then this is location page, and this is like every introduction and review section of each city. And this is a chat box, and then you could also change your background. Utrip has variety of features to enhance the user's travel experience. In the vacation page, the users can create their own travel plan and contact their friends. Also, users can change the background image freely and send text and photos through the chat. Next, there is a locations page, which shows the users different places around the world and suggests where to travel. For each location, there is a brief introduction and a section where the users provide feedback on it. The users can also get a list of recommended songs by clicking the button in the right corner. Code example. Our Python Flask app integrates the function to improve user interaction with the app. The music route allows users to receive recommended music based on location. It uses the chat completion function of a OpenAI API to generate a list of dictionaries with song and their artists. The transcription route transcribes audio into text and translate it into English. We first retrieve the uploaded audio from a link and then send it to OpenAI's audio translation function. The help route acts as a real-time assistant. It provides information and responses to users. When the user sends in a prompt, we will include both the latest message and the previous chat history for the AI to give the best possible responses. Each route covers definite functionalities that deliver different content and services to users. Firebase. In order to store the information and data generated by the user, we used Google Firebase as a cloud-based database and storage. In Firebase, we created a few database collections to store data such as user information, chat history, location information, and vacation plans that user created. We also used the authentication method to enable email password logins. For each message, we measure the number of times when the response contains an invalid characters and the number of times when the response fails to contain the correct format. Based on our experiment and visualization, message 1 was the most effective in terms of keeping the response in the correct format, with only 4% of the responses in the bad format or containing any invalid characters. The second and third message both had a similar number of badly formatted responses, 18% and 20%. However, the third message had over 50% of the responses containing invalid characters. This is likely to be the three ticks that we included in the question, but these can be removed by string parsing, so it will not affect the effectiveness of a program. It is rather counterintuitive that if we included the JSON examples in message 2 and 3, the error rate will go much higher. This might be an indication that GPT-4 understands human language better than code examples. Therefore, we decided to use the first message as our prompt for the AI model. Comparison with other travel apps. Trip created by Ling, and Zhang, provides a novel data mining-based approach to efficiently find the optimal trip which satisfies the user's travel time constraint based on the user's location. This research used machine learning techniques to create a trip plan for the user, where Utrip app lets the user to create their own plan based on the locations they want to visit. The use of optimization mechanisms in TripMine takes travel time constraints into account, which improves the efficiency and effectiveness of trip planning. But at the same time, it ignores users' own preferences, which we highlighted in our Utrip app. Conclusion. The limitations of this project include potential errors when using the AI chat box and the fact that it only functions when connected to the internet, meaning users cannot access it in areas without a connection. Additionally, the app does not offer personalized travel routes, which could be problematic for users navigating unfamiliar locations. Currently, we're using the standard GPT model, but one improvement could involve developing a customized GPT with enhanced capabilities to to act as a more effective travel guide. If I were to enhance this project, I would add a feature that allows users to create their own travel routes or request the AI to generate a route for them based on specific needs. This travel app is designed to make trip planning more convenient and enjoyable. With features like event reminders, it ensures that users don't miss any activities. Additionally, the AI chatbox provides real-time assistance and suggestions based on user queries. And these are my references. Thank you for listening.